afternoon, everyone, and welcome to our latest episode of MSME Masterclass. We are honored to welcome Mr. T.P. Jayakumar, Director, Excell Fabricoat LLP, a veteran mechanical engineer and distinguished shipbuilder, as today's MSME Masterclass speaker. With a remarkable career spanning over 3 decades in the shipbuilding industry, Mr. Jayakumar has made significant contributions across the defense sector, private shipyards, and more recently, as a successful entrepreneur since 2016. Mr. Jayakumar brings deep technical expertise and practical insights, having held senior management positions and roles at one of India's foremost shipbuilding companies. His leadership has consistently driven innovation, high precision, fabrication, and operational excellence, key pillars for MSMEs aspiring to scale in complex industrial domains. Complementing his engineering foundation, he also holds a diploma in naval architecture, shipbuilding, and ship repair from the Indian Navy. His work has been instrumental in advancing block assembly and alignment methodologies vital to modular ship construction. He specializes in managing dimensional tolerances and deploying advanced alignment tools, knowledge that MSMEs can directly apply to enhance efficiency and accuracy in their operations. Mr. Jayakumar will share his insights on minimizing steel distortion during welding, a challenge faced by fabricators and builders across industries. This masterclass will cover cutting-edge techniques and best practices and draw real-world scenarios and lessons learned, offering attendees a rare opportunity to gain from decades of frontline experience. Please join us in welcoming Mr. Jayakumar, who will lead us through an insightful session designed to empower MSMEs with the knowledge to build stronger, more precise, and distortion-free steel structures. Welcome, sir. Welcome on board.
Namaste. Thank you.
Sir, our first question to you is, what are the most common types of distortion that occur during welding, and why do they happen in the first place?
See, welding distortion occurs when heat causes uneven expansion and contraction in the metal being welded. This leads to misalignment, wrapping, and other defects. Basically, we can say the undesirable changes in the shape or the dimension of the workplace that occur during and after the welding process is called the distortion. Basically, there are 4 or 5 types of distortions we basically encounter during our work practices. The longitudinal shrinkage or longitudinal distortion is the common one, and the second one is the transverse, and the third one the angular, and the fourth the buckling and the bow distortion, what we call. The longitudinal shrinkage basically happens along the length of the welding what we do on the job. So it basically means contraction due to its heat input, and then when we start commence the cooling, it happens to the contraction. So this is the longitudinal shrinkage. And in the transverse, when we do the butt welding, basically on the butt weld, there is a tendency to shrink due to contraction, bringing the dimensional size in the transverse direction to bringing to the minimum. Means this is generally happens 0.2 millimeter to 0.4 millimeter based upon the weld input and the number of passes. So there is also shrinkage in the transverse. So that is called the transverse shrinkage. And in the angular distortion called because of it happens when it rolls out from the corner in the tangent view direction of the weld. So that is called the angular direction. And the buckling, so what we call in the shipbuilding or in the other area, is like when we do the stiffness welding on all the sides and the plate on the center is become tendence to buckle on the generally towards the heat area, it's buckle. So that gives you the dimensional error, and it give you the Ethiopian ribs, which will be like big panels and all. When we do it on the shipbuilding, it appears like a ribs on the starvation ribs in the ship. So that is a very bad appearance which we give. So these are all the common the distortion what we discussed. generally we encounter.
Sure. So could you also share with our attendees real-world examples of a poor welding technique which could have led to a major distortion and how it could have been avoided?
See, we generally encounter a lot of distortion in the shipbuilding because shipbuilding is a large volume welding occurs during the construction. So the people we all gives the direction of the welding due to our QA process or the quality assurance or the quality control process. We give a lot of inputs to the welders, but we employ the welders, those who are not maybe the highly skilled or the highly educated. They are only on the hands-on experience, they do the job. So there are chances of errors which can occur, and that will lead to a major damage in the dimensional or the distortion which can happen. So for a certain example, when we were doing some of the vessels like geotechnical research vessel, which was supposed to have the drill platform within the vessel testing. So for that one, there are drill towers which we were installed. So once we after the placement of the drill tower on board, we asked the people to follow some certain sequence of the welding to correct the or control the distortion, which they not followed, which has happened. The entire drill tower which is supposed to come in the very dimension accuracy, which has happened to a big correction we were supposed to do, and we corrected all these things. But generally we in a shipyard for the such an activity, we generally deploy or employ correct sequence and supervision before doing the job. So that area, the corrections can be done, or we can avoid the major dimensional distortion or dimensional corrections, dimensional mismanagement can be corrected.
Can you also help us understand what are the low-cost practices that can be adopted to minimize distortion effectively for MSMEs working with limited resources?
See, I will prefer the training. Emphasis on the point number one will be the training, which any fabrication or any area, the people need to be trained properly, like basic training, welding training, and distortion control methods. These can, these are the first low-cost method what we can do. Second is like use the backstep welding method. Like we have means the technology is used or the method is used in the welding process, that is a backstep method. And another one is the skip method. Like the welding, one you leave it, one particular length of 100 millimeter you do the welding, then you leave another 100 millimeter, then you start another 100 millimeter, so that the distortion which occur can be minimized. And another one is you use the clamps, proper clamps before doing the welding. Proper clamps to be used for fixing the job, so that the job, the tendency to distort or the deform is restricted. Another one is like the preheating of the thin sheets. Generally people think that the welding, when you do the welding there is a distortion, or when you heat there is a distortion. So this is one general people's myth, we can say. So to avoid that one, the thin plate can be preheated uniformly before doing the welding, so that the distortion can be avoided. And then is you set the correct procedures like voltage. The earlier you can see the welding machines we were using, like tapping from 100 amps to 200 amps. There is only 150 amps, you have only one tapping. but you don't have the control in between the this one. So that sort of welding machines we have to avoid. And the latest technology welding machines like inverter based welding machines, the correct voltage and the current and the electrode selection, the right electrode, because we have to use like where 2.5 mm electrode to be used according to the thickness of the plate, that we have to use the 2.5 mm instead of 3.2 or 1.5 mm. Like that is another one area which we need to control. These are the basic and the simple process which any industry can adopt to avoid distortion in the welding. And not only the major, one more thing my emphasis will be on the work table or the job which has to put on the correct leveled surface. When you put the job in an irregular shape table or an irregular shaped skid, it tends to deform according to the skid or the table which is we are provided. So my emphasis, the first means the most important thing will be on the platform or the table which we are making the job should be rigid, and it should be according to the straight as much as possible what we can do, so that the distortion can be minimized.
Got it. Now, sir, how much of a role does material thickness play in distortion, and how can MSMEs handle thin versus thick steel differently?
See, the thickness of the material is very important in every job. Like the material thickness, like 2 mm, 3 mm. Okay, it having the heat input or heat which can absorb is much more when we compare to the 10 mm plate or the 15 mm plate or 20 mm plate. So the thickness is very important, and it plays a major role in the any of the fabrication area for the controlling of the distortion. So as I mentioned in the first area, like the thickness, low thickness plates has to be preheated so that the undesired contraction can be controlled by preheating of the material. Like when we the contraction in the minimum thickness plate or 2 mm or lesser than that, the contraction rate is very rapid comparing to the 10 mm or 15 mm plate. The when the temperature increases, the elongation is also increased. But that when the temperature decreases, the contraction rate is also increases. So to avoid that one, we have to have a preheating of the job, which generally the people believe that one, it is the wrong practice. It is only required for the higher thickness. But whereas to control the distortion, preheating with the propane or the what we call LPG with the normal blowtorch heating prior to undertaking the job will give us a good result.
Okay. And sir, are there certain welding methods or processes that naturally reduce the risk of distortion compared to the others?
Yeah. See, the olden tradition of using arc welding, or we call it as a stick welding or thing, this gives you more heat input and the more distortion into the job. So nowadays there are new technologies which has come, like pulse welding, double pulse welding, then the TIG welding, MIG welding. MIG welding is the metal inert gas welding, tungsten inert gas welding. These are all the new methods which will give you the lower heat input and which will reduce the distortion and a balanced stress distribution also. So and SMAW welding, submerged arc welding, which we generally use for the higher thickness of the plates, which a higher welding electrode diameter, which will give you reduced stress and deformation. And also we can use basically what happen is the time and the heat input and the speed are the governing factors of the distortion. So when we use the speedest method with a steady and constant voltage and the constant right welding method will reduce the distortion on the jobs, whatever we are doing.
So now help us understand the weld sequence. What role does it play in controlling distortion? And could you share a practical scenario where changing the sequence could have made a difference?
Yes, of course. The sequence in the sense according to the job and according to the availability of the welder, availability of the welding method, we generally go for the different sequences of the welding. In the sequence in the sense we generally, to avoid the welding distortion, what we have to do is from center of the job, any welding, like you can see in some of the robotic weldings, when it performs, they scan first. Okay, the job is scanned by the robot, and then they start from the center of the job, then it goes towards the outward to the job. That gives you the right result of the job, and it gives you the good finish. Rather than people, what they do is when they start the job, they will start from one end and they go and keep on moving towards the other end. Then it starts wrapping, and it will give you the deformation, undesired forms, undesired shape, everything we will be getting. So instead of that one, start from the middle and go towards the outward of the job, so that the distortion is minimized, and whatever they do the job, that should be quick enough and should not wait for the people generally take rest in between, then you restart it. These are all give you the undesired pooling and undesired shapes of the deformation. And also when we do the big panels welding, you deploy 2 to 3 or 4 welders starting from center towards the 4 corners they can move, so that the job will be in a desired shape and without a deformation, and the work can be done within a stipulated time frame also.
Got it. And so how important, according to you, is fixture design in managing distortion? And what simple fixture ideas can MSMEs implement without major investments?
See, fixture, as I told you, fixture design plays a very critical role. Like I told you, the skid or the table, which I was discussing in the previous questions, which you were asking me. So it plays a major role. When a job need to be done on a particular straight format, we have to have a skid or the fixture or the table should be on the straight level, so that the job give you the right or our desired shape after the welding is completed. So it gives you the it is a very important role the fixture plays in the welding to avoid the distortion. And there are simple methods like C-clamps, the jigs, and the lot of vise grips available in the market, so that you hold the job properly on the skid or on the table, so that the job does not move or it does not tend to the deformation during the welding or after the welding process is done. There are angle support. Generally, you can use the old scrap angles also to put the support, lock the job, and before doing or the commencement of the welding, we have to lock the job properly, so that it does not allow the warping or the deformation to take place. So that is also one important this one. And when the shaped the things jobs we do, so it is very important to give the locking or the arresting, some of the panels when we do and all, we give the back support so that it doesn't tends to deform or distort during the welding or after the welding. So these are all the simple methods which we will be able to implement during welding in the means any industry like MSME or in the shipbuilding industries. It is possible to do in the better manner. And we can, some of the areas like the people uses magnetic lamps, which magnetic lamps like these are all we use largely in the shipbuilding industries because when we do the job, we need to do the tacking to maintain its position so that it doesn't tend to deform during the welding or after the welding. So we use magnetic fixtures which can be fixed easily. These are all the permanent magnets which can be used with a lever to fix the job, so that once the job is done, we can remove it. This will avoid a lot of unwanted grinding or unwanted the manpower used for the fixing or tack welding can be avoided. This is very important one. The recent deployment of the magnetic fixtures in the shipbuilding or in the industries, giving the good result and good productivity also. So this is a very important tools which will give you the support in any of the industry. And we can use the aluminum backing bars like items which will absorb the heat also, and it will act as a heat sink to absorb the heat during the welding. So that copper or aluminum backing strip is also one of the important, plays an important role in the small or MSME sector, which can be used for the control of the distortion.
Okay, and sir, can you share a case where pre-weld preparation made a clear difference in distortion outcomes?
Yeah, definitely, because the pre-weld preparation means we the job need to be kept. We know that when some of the weld will means tend to distort during the welding or after the welding or after the cooling of the process of the job. So we can preset the job to a certain angle, which and do the tack welding, number one. And some of the long jobs which we undertake in a means we do a lot of hatches, hatch covers, or some sort of that long jobs we do in the shipbuilding. So we or the block fabrication like a 20 meter by 12 meter and 25 meter, that sort of big blocks when we fabricate, we pre-stress the job. Before doing the welding, we pre-stress it so that the center area we give 10 to 15 mm dimension, additional dimension, and the outer end we pull towards to the lock the job, so that after the welding, such a huge job, it because of the welding contraction, it comes back to the original shape, and which will be perfectly aligned to the dimensional control. So that is another one process we generally do in the shipbuilding. That is the setting procedure before the welding. And of course the correction like supports, angles and all we give to arrest the distortion which is happening before the welding process is started.
So now in terms of welding parameters, could be voltage, current or speed, what should MSMEs watch out for to control distortion?
See, voltage, the current and the speed plays a vital role in the welding. Like when we use the over voltage, what will happen is the voltage, we get a very broad welding, which is undesired one. And when we have a lower voltage, it will not weld properly. It will give you a narrow weld bead. And the current, when say current, the ampere is plays a very important role. If the ampere is more, it will have like more warpage or more distortion, and the sagging, the blow means the weld will sag towards down below where the welding has performed, and the speed If you are not using the proper speed on the weld, what will happen? We will get more weld, fillet weld or the butt weld area. We will have the more weld material deposition will be there. That will also add to the fuel for our distortion what we are trying to control. So the speed is very important. The voltage and the current is very important factor in the welding. So when we select the welding, we have to have the right when we select the thickness of the plate or the electrode what we use, we have to use the correct as per the technical data sheet of the welding electrode or the filler material what we are using it. According to that one, we have to use the right voltage and current and speed for the job. So this is very important role when it comes to the any sector which is doing the job.
So how can post-weld treatments like straightening or stress relieving be used wisely without adding unnecessary cost or complexity?
See, the post-weld treatment is give you the, it is very important and it is required to be done. It is a very cheapest method of doing the distortion correction. Like basically the post-weld heat treatment done on the area or to correct the distortion. What we do is on the other side of the welding, where we have performed the other side of the welding, we do the stress relieving in the heat affected zone. Like we use the 3-nozzle torch, basically comes for the stress relieving. And some other methods are like hammering and pinning is also used as a cheapest method for stress relieving. It's a low cost method. And some other methods are like rolling and bending. After welding is performed, we can pass it through the rolling machine and make it straighten. These are all the simplest method of the low cost the preheatment or post heat treatment methods which can be used in the MSME sector.
So according to you, are there any differences in distortion control between manual and automated welding, and how can MSMEs decide what's right for them?
See, automatic welding basically it controls with the speed, the welded deposition. These are all automatically controlled. So we get a proper result in the automatic welding. But when it comes to manual welding, it is very difficult to control. If the people are not trained properly or the proper method we are not used, okay, then there is a chance of most what we can say the distortion or the deformation can happen. For the small scale or custom work, we can use for the low cost, low volume production, we can use the manual welding process. But whereas repeated nature or and reproduced nature of the job can use the automated welding. Like you want to produce n numbers of the similar type of jobs which some companies are making, they can get into the automation. This automation will definitely give them the good result and without a distortion and this one. But when it comes to the piecemeal basis of job which we are some MSME sectors are undertaking, they have to use like skilled laborers and low volume this one thin materials which they are using. They have to go for the manual welding, but a proper training and proper selection of the build material and proper selection of the welding machine is also plays an important role in this one. And some of the areas like the people can use the hybrid approach in the MSME, like a semi-automated MIG welding machine, and also there are some welding wagons which comes into the currently into the market, which give you the good output as well as a good result when we comes to the welding and welding application. So the hybrid approach in the MSME sector would be the best approach, I think, to increase the productivity. Also, it will give you the good result on the job, like without distortion and without warping and all this can be. It is desired and it is advisable to go with the hybrid system.
Got it. Now, sir, according to you, how do base metal properties like carbon content or grain structure affect distortion? And are there any more distortion-friendly steel grades?
See, this low carbon, is more ductile and less prone to distortion. Okay, this carbon percentage less than 0.3. Like we use the shipbuilding steels, basically these are all or IS 2062 grade B. These are all comes under 0.23 and 0.22% of carbon. These are all generally prone to less. These are all ductile and less prone to the deformation. And the medium carbon steel has the highest strength, but it can develop the residual stresses when it comes to the heat input and the cooling process when it comes. And high carbon steels more prone to the cracking. Basically, like the cast iron and all, when a heat input goes, there is a chance of distortion and rapid cooling. This all due to these all factors. These high carbon steels are prone to means more vulnerable to the distortion and the damage. And the grain structure, when we talk like fine grain structure as the fine grain steel, which is having a better toughness and resistance to distortion. And the coarse grain steel expands and contrasts unevenly and increase in distortion risk. And annealed or heat treated uniform grain structure reduces stress buildup, and these are all distortion friendly steel grades like stainless steel. Stainless steel means the stainless steel is having very coarse grain structure, and that's why it it doesn't it is not vulnerable to the deformation and this one. But in that one also, any weld like heat input and the heat the cooling happens. There it happened that there is a tendency to distort and deform, but there are certain measures like fixing. These are all has to be happen during any welding or bracing or such kind of process has to be happen. Like the stainless steel, as I told, it is however a lower thermal conductivity and reduce the heat spreading and the distortion. But yes, we have to, by saying that one, these are all not upon to distortion and deformation. It's a wrong concept. We have to have a proper check and balance before doing the stainless steel also.
Now, sir, according to you, are there any ideal joint designs or weld geometries that help reduce distortion across most of the fabrication scenarios?
Yeah, see, weld joints, weld design, joint design is very important role, plays a very important role in the during the welding. Basically, the double V joints given on the job will give you the right desired output, like with minimal deformation. Like the one area, the butt, when we do the butt welding, if you are going for a single V and doing from the welding from the one end, it start weld deposit on the one area is more, one area only the heat input is more, so there is a tendency to the warping or the deformation, like the transverse deformation or transverse distortion. So to avoid that one, we have to give the double V joint. I prefer basically rather than going for the gouging or the single V joint, to have a better and desired result, I generally prefer a double V joint, which will be giving you the less distortion. And I recommend always for the double V joint for the better result and better appearance.
Now, sir, tell us, can tack welding be used strategically to control distortion? And could you share examples of how that works?
See, yes, of course, you means when you talk about the tack welding is nothing but, like it is an acting as a fixture. Basically, it acts as a fixture. Like when we do the job, like in an open, I can show you, like when we do the job, when we from butt joint, from without a tack welding, it overlaps and it comes to the overlap and come one over the other. So to avoid that one, when the jobs are placed in the correct dimensional requirement and does the tack welding, and then the people perform the job, it doesn't deform or overlap, get into the one top of another. That kind of scenarios can be minimized. Or else when we do a lot number of joints to be performed, so the fitter basically does the fit up. So he places the job on in the correct dimension. Then he does the tack welding. He performs the tack welding to maintain its dimensional position and the shape. So after the welding or during the welding, it does not collapse or it does not deviate or deform from the required position. So मैं ऐसे आपको बोलूंगा कि you have to use that one. You tack weld, the position has to be corrected, placed on properly, then you perform the job. Otherwise, pipe will be joined like this, without doing the tack welding. After the job is done, the pipe will be half only, will be the fluid which you are supposed to pass. It will be only half of the fluid only will be allowed to pass. The desired result we will not get. So these are all the collapse. Basically, the people, they have to, otherwise some like, or we can say what, like our car or any other equipment what we manufacture or scooter, when we does not place the proper the things in the place, the axle will be on one direction and the tire will be on another one direction. So keeping the position of the job, the dimensional accuracy is very important. Otherwise, it is a mess. So we will not be able to get the proper or desired result.
Now, sir, help us understand, according to you, what are the biggest myths or misconceptions about distortion that you have encountered amongst small fabrication shops?
See, the biggest myth, or when we go to the people, they take it as granted, like distortion is unavoidable. Ye to hota hi hai. That attitude is the biggest drawback, or what we misconcepts about the distortion. Okay, there are methods, there are ideas, there are procedures to control and correct. One is prevention, another one is cure. So these are all possible, but the people say distortion is unavoidable is a misconception, and the biggest myth what I would like to say and share you that one. And another one, the misconceptions what people generally say, distortion only happens in thin metals. Okay, distortion happens only in thin metal. That is also another one misconception. Every area, the thinner, thicker or medium, everywhere generally the distortion happens. But distortion, as earlier also my statement which I gave you, distortion happens because of the uneven heating and uneven cooling happens on the workplace or on the job. So this happens everywhere. Okay, so there are methods like more heat equals stronger weld. People, another one concept is stronger weld banao, वो बहुत ज़्यादा weld banao. Okay, that is another one. Strong करने के लिए, it is also a wrong concept, because आपको ज़्यादा weld डालने के लिए ज़रूरत नहीं है. Because what is necessary, that much only we have to do. The people do the butt weld, and it looks like additional one ring or additional weld profile they give. That is not necessary. If the weld material is covered with the proper area, the area means without undercut or without concave, a slight convex is enough for the butt weld, the profile. So the another misconception which told the people, no, stronger weld, that is another one, this one. Okay. And people think about clamping completely prevents the distortion. That is another one misconception. Clamping cannot alone prevent distortion. Means it is the culmination of all the methods what we use is the good result what we get. Like we have to use the proper clamping, we have to use the right welding method, we have to use the right current, ampere, the speed. All the culmination is this one. So the clamping alone cannot prevent the distortion. Okay, and preheating is only for thicker steel. The people generally think for the solidification rate to control all these things, the people believe that the preheating is only for the thicker material. That is a misconception. Like which I told you, for the thinner material, before we do the welding, performing the welding, we can go for a preheating with the smaller means the propane torch, using the just preheat it, so that it does not rapid cool, it doesn't get into the rapid cooling area. Okay, then post weld, post weld weld treatment, heat treatment clears everything. The people having that misconception, because you do the post weld heat treatment and the distortion, deformation, everything can be controlled. Yes, there are countries like Japan, the Korea, and they adopt the post weld treatment for the distortion correction also, like using the line heating method. But that is not the alone method available, because as I told you, there are so many steps which we have to use it. So the post weld treatment, heat treatment method is not alone can control the welding distortion. And skip welding, or the what we in the shipbuilding what we call is intermittent welding or the chain welding, that is the weakest welding. That is another one, the misconception people use it, but it is not. It is a proven, calculated on the welding. We generally in the shipbuilding we use the welding schedule, like how much throat thickness, how much weld deposit to be given in all the area. These are all pre-calculated, designed with the design firms using the latest technologies. So that skip welding weakens the joint. That is another misconception. Okay, so another one is it's an automated welding eliminated deformation or distortion. It is also another one misconception. Yes, it certainly helps you to control the deformation or distortion, but it cannot automate welding cannot eliminate the deformation or distortion in the welding. I emphasize on the point that deformation or distortion is unavoidable, is the biggest misconception the people generally follow in the any manufacturing sector is the biggest misconception what I feel it.
Thank you, sir, so much for sharing so many details and examples on this one. Moving on, so when working on structures with tight tolerances, how can MSMEs measure and monitor distortion practically and cost effective?
This is the job, as I told you, the deformation starts from the parameter setting to everywhere this one goes. So we can use some of the dial gauges where, cylindrical or some high tolerance jobs. When we do, the dial gauges can be kept. Vernier calipers can be used, to have the precise dimensional check for the smaller, smallest deformation during the welding. And for the larger one, we can use the straight edge or the steel rules. The larger steel rules can also be used. Some of the method we use in the shipbuilding is the thread, like what we call is line dori, or the thread, long thread, which we will be able to use the measuring of the. This is the simplest method to find out how much deformation has happened. And there are laser meters, laser technology, distance meters, and laser measuring tools can be used for in a larger scale with structural alignment. This can be used. And there are optical comparators which comes in the market, which can use for the measuring of the distortion. But cost effective, I can say, like up to laser or measuring tapes, the line dories, or the digital vernier or digital gauges. These are all the enough for any industry to measure the deformation and distortion during or after the welding.
Now, so my next question to you is around quick on-floor tests. Are there any quick on-floor tests or indicators that MSMEs can use to predict potential distortion during the planning phases?
See, this is there is no a test as such. Floor test or a thumb rule or something, we cannot use it. But for a longer one, if the long jobs are there, then we have to go for the pre-setting or pre-stretching of the jobs. And there we can predict this much 10 to we use for 8 mm, 8 mm for a 10-meter job, or 13 to 14 mm we use for a 20-meter long job. We use the pre-stress methods. So these are all the thumb rules, and according to the job sizes and the thickness of the material, we cannot predict, but one can say, or these comes with the practical experiences and the data what we collect, when we perform job, we have to collect data based on what we perform, keep the data, and from that database we can implement such a measuring tools or test we can apply on the job. Such there is no when you ask if there is any hardened this one methods, there is nothing such, but we can, with our practical experience and our data what we base collect on that one, we can definitely we can predict, and in the planning stage itself.
So talking about digital tools or simulation softwares, do you think they can help predict and manage distortion, and are there any accessible or relevant are these accessible or relevant to MSMEs?
Yes, there are, by using simulation-based distortion compensations, precision, for the precision or the other components can be used in the this one MSME sector. Like there are SOLV, harmonic analysis software, and advertised lab research. They are providing some of the 3D data scan, such kind of equipment. Softwares are there in the industry, which can MSME sector can use for the distortion prediction and all. That is what only we generally, does not use such kind of tools or software into the shipbuilding industry per se. Or I have gone across into the nuclear energy, nuclear sections and all. There also we are not used such kind of tools. But of course, there are softwares available in the market, which can who all are affordable to use that one. They may be able to, or such a precision job. Yes, they may be able to use such kind of tools.
Okay. So in a high mix, low volume environment, typical of many Indian MSMEs, how should you prioritize distortion control measures?
See, I will, distortion control measure, I will, use the welding machines, okay? Selection of the right welding machines. As I told you earlier, we were using all the thyristor welding machine or the transformer welding machines, okay? So you go for the selection of the right welding machines and the right process like TIG welding or the SAW welding or the MIG welding process, which we can use it into the low volume or high volume or any region we can use that one. There are new technologies comes up with the pulse machines, okay, which will be giving you the right right current and ampere for the where we will be using like a 238, 250 amps, but the pulse welding machine will be able to use that that job also can perform like with 130 and 120 amps. That 120 amps is the reduction in the current will give you the better result, okay. And another one is like you use the welding wagons, which I told you in this one, which is the part of semi-automation, which give you the good output as well as the good productivity and also good speed, appearance, everything. So that can be used in the MSME sector or in any of the in manufacturing industry. Will give you the best result in the this one. These are all the some of my takeaways which we can use it in the high-end low volume environment of in the manufacturing structure.
So finally, if an MSME had to invest in just one capability, whether it's a tool, a training, or a method to tackle distortion better, what should it be and why?
See, I will emphasize on training. See, the training, as you are aware, the training within during the Second World War, what the countries has used to develop the people to use the right method or the right practices or the right procedure. I emphasize basically on the training. The people need to get a proper training. They have means any company have to invest in training so that the people are ready for the future. Like any in the any eventuality, the people with the right training and the right approach, they are ready for the taking up any eventuality or any circumstances can be met with the proper training from within the industry or within the company. Or what we call the training within is an important factor on every industry or any industry. This is what I emphasize. My first and final call will be on training.
And with that, we've come to the end of today's episode. So thank you so much for being with us and for sharing your insights on minimizing steel distortion during welding. It's been lovely having you, sir.
Thank you so much having me here and giving me this opportunity to share my views, my experience, what I come across from my 30 years of experience in the shipbuilding and the nuclear and various oil and petrochemical region. So This is very pleasure, participating in this one and giving me the opportunity. Thank you so much. Jai
It's
Hind.
been an honor. So it's been our honor. For our attendees who are online, if you'd like to see this current episode, if you've missed any part of the current episode, please go on YouTube, type GSW1 MSME, and you will find all the episodes uploaded there. Thank you so much once again, sir. Bye-bye.
Thank you. Jai Hind.